plus 1, and x would be between, this is where most people have had the problem. They thought x is any real number. No. No, 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 no. You are on a segment. X has the values between this value, whatever that is on the x-axis, and that value. So x equals 1, x equals 2 are the endpoints. How do you write a parameterized equation? And that should help you very much on the web work homework on that problem for such a function. Well, you say, wait a minute, Magdalena, this is a linear function. It's a piece of cake. I have just x plus 1. I know how to deal with that. Yes, but I'm asking you something else. Rather than writing the explicit equation in Cartesian coordinates x and y, tell me what time it is, and then I'm going to travel in time. I want to travel in time, in space-time, on the segment, right? So y of x equals x plus 1 has what parameterization has? Infinitely many parameterizations, somebody will say. You told us that it has infinitely many. Why do you insist on one? Which one is the most natural and the easiest to grasp?
0 to 1.
0 to 1 is not a parameterization.
Time 0 to 1.
So what is a parametric equation of a curve in general? If I have a curve, y equals, I'll start with x. X equals x of t and y equals y of t represent the two parametric equations that give that curve's equation in plane. In plane, where the time t belongs to a certain interval I, that's a mysterious interval. I don't really care about that in general. In my case, which one is the most natural parameterization, guys? Take x to be time. Say it again, Magdalena. Take x to be time. And that will make your life easier. I take x to be time, and then y will be time plus 1, and I'm happy. So the way they asked you to enter your answer in web work was as r of t equals, and it's blinking, interactive field for you. You say, okay, t plus 1. And I'm not gonna solve your problem, but your problem is similar. Why? Because r of t, which is the vector equation of your line or curve, would give you the position vector, which is what? Wait a second, let me finish. X of t times I plus y of t times j is the definition we gave last time. Go ahead.
Where'd you get r of t and what is it?
I already discussed it last time. So since I'm reviewing today, just reviewing today chapter 10, I really don't mind going over a review, but please keep in mind this is the first and the last time I'm going to review things we did last time. So what did we say a position vector is for a curve? When we talked about the drunken bug, we said the drunken bug is following a trajectory. He or she is traveling in time. I have a given frame x, y, z, system of coordinates, system of axes of coordinates with a certain origin. Thank God for this origin, because you cannot refer to a position vector unless you have a frame, an original frame, a position frame, initial frame. So R of t represents the vector that originates at the origin O and ends exactly at the position of your particle at time t. If you hate bugs, this is just a particle from physics that travels in time t. So,
okay, so that R of t is representing the parametric equation.
Yes, sir, exactly. In a plane where z is 0, so you imagine the z-axis coming like that. Z is 0, this is the xy plane, and I'm very happy I live on the floor. This bug lives on the floor. He doesn't want to know of 3 dimensions, so what is he going to do? He's going to say, plus 0 times k that I don't care about because the position vector will be given by or for a plane curve.
So if this was in 3D space and we had 3 equations, so it was like z equals is equal to 2y plus x plus 1, then it would be, then how would we do that?
Let me remind this in general the way I pointed it out last time.
Okay.
R of t in general as a position vector, we said many things about it. We said it is a smooth function. What does it mean? Differentiable with derivative continuous. What did, actually that's C1. What else did we say? He said it's a regular vector function. What does it mean? It never stops. Not even for a second will the velocity of that be 0. And when we introduced it, and I cannot teach the whole thing all over again, but I'll be happy to do review just today. It's gonna be x of ti plus y of tj plus z of tk. There is a way to write it like that, or a similar way to write it as x of t, y of t, z of t. Now, different books use different notation. I want to warn you about that. Some people like to put braces like angular brackets for this triple. Some people like, because it's a vector, and that's the way they denote vectors. Some people like just round parentheses, but practically these are the coordinates of a position vector with respect to the ijk frame. So, since we talked about this already, some simple examples have been given. One of them was a circle in plane, another circle in plane of a different speed, a segment of a line. This is the segment of a line. What else have we discussed? We discussed something wilder, which was the helix of different speeds. All right, so very good question for him was, so is this x of t t? Yes. Is this y of t t plus 1? Yes. Is this z of t 0 in my case? Precise.
So if you gave value to z, what would you choose to make t when you parameterize?
Okay, t in general, if you are moving, you have an infinite motion that comes from nowhere, goes nowhere, right? Okay. Then you can say t is between minus infinity plus infinity, and that's your I interval.
What I'm saying.
But in your case, you think, oh, I know where I'm starting. So to get equal to 1, t must be 1. So I start my movement at 1 second. And I end my movement at 2 seconds, where x will be 2 and y will be 3.
Well, I mean, so you said x equals t, and you took that from the y equals x plus 1. If you had the third variable t, what would you...
It's not a third variable, it's the time parameter. So I work in 3 variables x, y, z in space. Those are my space coordinates. The space coordinates are functions of time. So it's all about physics. So mathematics sometimes becomes physics. Thank God we are sisters, even stepsisters. X is a function of t. Y is a function of t. Z is a function of t. Right? Am I answering your question, or maybe I didn't quite understand the...
Well, I understand how to parameterize in a plane. How do you do it in space?
In space, you are already here, so if you want to write this not in plane but in space, your parametric equation is ti plus t plus 1j plus 0k for this example, and you are in R3. We live in R3. Alrighty? We live in R3. Okay, let me give you more examples because I think I'm running out of time, but I still have to cover the material, eventually get somewhere. However, I want you to see more examples that will help you grasp this notion better. So guys, imagine that we have a space R3, that could be Rn, in which I have an origin and I have a frame ijk, orthogonal frame, and somebody gives me a position vector for a motion, that's a regular curve, and that's x of ti plus y of tj plus z of tk. And since his question is a very valid one, let's see what happens in a planar case. So I'm gonna deviate a little bit from my lesson plan, and I say, let's be flexible and compare that with a planar curve, because in the process of comparison, you learn a lot more. If I were to rewrite the book, maybe I would rewrite the book like that. So this is the spatial curve in R3. Imagine if the trajectory of a bug or a particle in physics, and this is a planar curve. Planar parameterized curve in R2. What's different? What do we know about them? Quick review of section 10.2. What I hate in general about professors is if they are way too structured. Mathematics cannot be taught in sections where you say, oh, section 10.2 is only about velocity and acceleration, but section 10.4 is about tangent unit vector and principal normal. Well, they are related. So it's only natural when you talk about section 10.2, acceleration and velocity, that from acceleration you have a induced line to tangent unit vector, and later on you're gonna compare acceleration with a normal principal vector. Sometimes they are the same thing, sometimes they are not the same thing. And it's a good idea to see when they are the same thing and when they are not. So in section 10.4, we will focus practically on Tn and B, the Frenet frame, and its consequences on curvature. We already talked about that a little bit. In 10.2, practically, we didn't cover much. I only told you about velocity, acceleration. However, I would like to review that for you because I don't want to risk losing you. Well, I'm going to lose some of you anyway. Two people said this course is too hard for me. I'm going to drop. You are free to drop, and I think it's better for you to drop than struggle. But as long as you can still learn and you can follow, you shouldn't drop. So try to see exactly how much you can handle. If you can handle just a regular section of Calc 3, go to that regular section. If you can handle more, if you are good at mathematics, if you have always been considered bright in mathematics in high school, then stay here. Otherwise, go, don't stay. All right, so the velocity is r prime of t, the acceleration is r double prime of t. We have done that last time. We were very happy. What would happen in planar curves in R2? The same thing, of course, except the last component is not there. X prime of ti plus y prime of tj, and there is a 0k in both cases. So all these are vectors. At times I'm not going to point that out anymore. The derivation goes component-wise, so if you forgot how to drive, or you want to drink and derive or something, then you don't belong in this class, right? So again, make sure you know the derivations and the integrations really well. We're going to work some examples out just to refresh your memory, but if you have struggled with differentiation and integration in Calc 1, then you do not belong in this class. All right. Let's see about speed. It's about speed, it's about time. It's about time to remember what the speed was. The speed was the absolute value, or the magnitude. It's not an absolute value, but it's a magnitude of the velocity vector. This is the speed. And the same in this case. If I want to write an explicit formula, because somebody asked me by email, can I write an explicit formula? Of course, that's a piece of cake, and you should know that from before. X prime of t squared plus y prime of t squared plus z prime of t squared under the square root. I was not going to insist on the planar curve. Of course, the planar curve will have a speed that all of you know about, and that's going to be square root of x prime of t squared plus y prime of t squared. You should do your own thinking to see what the particular case will become. However, I want to see if you understood what derives from that, in the sense that you should know the length of an arc of a curve. What is the length of an arc of a curve? Well, we have to look back at Calculus 2 a little bit and remember that the length of an arc of a curve in Calculus 2 was given by what? So you say, well, yeah, that was a long time ago. Well, some of you already told me, remember that as being integral from a to b of square root of 1 plus y prime of x squared dx. And you were freaking out thinking, oh my God, I don't see how this formula from Cal 2, the arc of a curve that you travel between time t equals a and time t equals b will relate to this formula. So what happened in Cal 2? In Cal 2, hopefully you had a good teacher, and hopefully you've learned a lot. X is between a and b, right? What did they teach you in Cal 2? They taught you that you have to take integral from a to b of square root of 1 plus y prime of x squared dx. Why? You never asked your teacher why. It's bad. You should do like he does. You should ask why every time. They made you swallow a formula by memorization without understanding this is the speed. And now I'm coming with the good news. I have a proof of that. I know what speed means when I'm moving along the arc of a curve in plane. Okay? So, what is the distance traveled between time equals a and time equals b? It's going to be integral from a to b of the speed. Right? This is the same when I'm driving from Lubbock to Amarillo or anywhere else. Good. Now, what they showed you, and they fooled you into memorizing that, is just a consequence of this formula. Because of what he said. Why? The most usual parametrization is going to be y of t equals t. X of t equals t, x is t, and y of t equals y of t. So again, x is time. In many planar curves, you can take x to be time, thank God. And then your parametrization will be t, comma, y of t, because x is t. And x prime of t will be 1, y prime of t will be y prime of t. When you take them, squish them, square them, sum them up, you get exactly this one. But you notice this is the speed. What is this? The speed, absolute value of r prime of t, which is speed. You see that what they forced you to memorize in Cal 2 is nothing but the speed. And I could change the parametrization to something more general. Now, can I do this parametrization for a circle? No. Why not? I could, but then I have to split into the upper part and lower part because the circle is not a graph. So I take t between this and that, and then I have square root of 1 minus t squared on top, and underneath I have minus square root of 1 minus t squared. So I split the poor circle into a graph and another graph, and I do it separately. And I can still apply that. But only a fool would do that, right? So what does a smart mathematician do? A smart mathematician will say, okay, for the circle, x is cosine t, y is sine t, and that is the parametrization I'm going to use for this formula, and I get speed 1, and I'm going to be happy, right? So it's a lot easier to understand what a general parametrization is. What is the length of an arc of a curve for a curve in space? There's the bug. Time equals t0. He's buzzing. And after 10 seconds, he will be at the end. So it goes bzzz, jump. Okay. How much did he travel? Integral from a to b of square root of x prime of t squared plus y prime of t squared plus z prime of t squared, no matter what that position vector x of t, y of t, z of t was. So you take the Coordinates of the velocity vector, you look at them, you square them, you add them together, you put them under the square root, that's going to be the speed. And displacement is integral of speed. When you guys learn in school, your teacher oversimplified the things. What did your teacher say in physics? Space equals speed times time. Say it again. He said space traveled is speed times time. But he assumed the speed is constant, or constant on portions, like piecewise constant. Well, if it's a constant, the speed will get the heck out of here, and then the space will be speed times b minus a, but b minus a is delta t. In mathematics, in physics, we say b minus a is delta t. That's the interval of time that the bug traveled, or the particle traveled. So he or she was right. Space is speed times time, but it's not like that unless the speed is constant. So he oversimplified your knowledge of mathematics and physics. Now you see the truth. Space is integral of speed. Okay, now we understand. And I promised you last time that after reviewing, I didn't even say I would review anything from 10.2 and 10.4. I promised you more. I promised you that I'm going to compute something that's out of 10.4, which is called a curvature of a helix in particular, because we looked at curvature of a parametric curve in general. I want to organize the material of review from 10.2 and 10.4 in a big problem, just like you will have in the exams, in the midterm and in the final. I don't want to scare you, I just want to prepare you better for the kind of multiple questions we are going to have. So let me give you a funny looking curve. I want you to think about it and tell me what it is. A and B are positive numbers. A cosine t, A sine t dt will be some sort of funny trajectory. You are already familiar to that. Last time I gave you an example where A was 4. Oh my God, I don't remember. You need to help me. Exad has the
443.
I took those because they are Pythagorean numbers. So what does it mean? 3 squared plus 4 squared equals 5 squared. I wanted the sum of them to be a perfect square, so I was playing games. You can do that for any A and B. Now what do I want? A. Like in 10.2, rewrite R prime of t, rewrite R double prime of t. So it's a complex problem. In B, I want you to find t as R prime of t over, who remembers the formula? I shouldn't spoon feed you that. Absolute magnitude. Actually, it's more correct to say magnitude, right? Very good. And what else did I spoon feed you last time? I spoon fed you n. Let's compute n as well as part of the problem. T prime of t over t prime of t in magnitude.
So in B, you're looking for the tangent unit vector.
Tangent unit vector.
And then you're looking for normal.
Yes, sir. And okay, would you like me to also give you something like a grading grid? How much everything would be worth? Imagine you're taking an exam. Why not put yourself in an exam mode so you don't freak out during the actual exam? C will be another question, something smart. Let's see, reparameterize in arc length to obtain a curve rho of S. Why not R of S, like some people could use it and some books use it? Because if you reparameterize in S, it's going to be the same physical limits but a different function. So if you remember the diagram I wrote before, little r is a function that comes from interval I, time interval, to R3, and rho will be coming from a j to R3. And what is the relationship between them? This is t goes to s, and this is s goes to t. What is d, I'm asking you? Well, if you did see, of course you know what the arc length parameter will be. It's going to be integral from 0 to t, or any t0 here, of the speed. of the speed of the original function in t. D tau, maybe tau is better than the dummy variable t. And E, I want, you say, how much more do you want? I want a lot. I'm a greedy person. I want the curvature of the curve. And you have to remind me, some of you are very good students, better than me. I mean, I'm still behind with a research course that I have, research paper that I have to read in 2 days in biology. But this curvature of the curve had a very simple formula that we all love. For a mathematician, it's a piece of cake to remember it. K, that's what I like about being a mathematician. I don't need a good memory. Now I remember why I didn't go to medical school, because my father told me, well, you should be able to remember all the bones in a person's body. And I said, Dad, do you know all these names? Yes, of course. And he started telling me. Well, I realized that I would never remember those. But I would remember this formula, which is arm rho. In this case, if our R is Greek rho, it's going to be rho double prime of what? Of S. Is this correct what I wrote? No. What's missing? The acceleration in arc length, but in magnitude, because that's a vector, of course. This is a scalar function. Anything else you want, Magdalene? Oh, that's it. All right. So I want to know everything that's possible to know about this curve from 10-2 and 10-4 sections. 10-3 is skip, 10-5 is skip. You are happy about it? Yes, sir?
The parameter on D, is it a t, and what's the integral? What's on the bottom?
That I erased when I wrote that one. It was there, t0. So I can start with any fixed t0 as my initial moment in time. I would like my initial moment in time to be 0, just to make my things easier. Are we ready to solve this problem together? I think we have just about the exact time we need to do everything. First of all, you have to tell me what kind of curve this is. Of course you know, because you were here last time. Don't skip classes because you're missing everything out, and then you will have to drop or withdraw. So don't skip class. What was that from last time?
Helix.
It was a helix. I'm going to try and redraw it. I know I'm wasting my time, but I would try to draw a better curve. What's the equation of the cylinder that the helix is sitting on? What's the equation of the cylinder? That's a quadric that you're all familiar with, on which my beautiful helix is sitting on. I taught you the trick last time, don't forget it.
A over 4 cosine t squared plus A over 4 sine t squared.
So we do that, very good. X is going to be, let me write that down. X is cosine t, Y is A sine t. And that's exactly what you asked me. And Z is BT. And then what I need to do is square these guys out, as you said very well. I don't care about Mr. Z, he's not in the picture here. X squared plus Y squared will be A squared, which means I better go ahead and draw a circle of radius A on the bottom, and then build my, oh my God, it looks horrible, the cylinder based on that circle. Guys, it's not straight, I'm sorry. I mean, I can do better than that. Okay. Good. So I'm starting at what point? I'm starting at A0, 0, time t equals 0. We discussed that last time, I'm not going to repeat. I'm starting here, and two of you told me at t equals pi over 2, I'm going to be here, and so on and so forth. If I ask you one more thing for extra credit, what is the length of the trajectory traveled by the bug, whoever that is, between time t equals 0 and time t equals pi over 2, let's say that's extra credit. So oh my God, 20%, 20%, 20%, 20%, 20%, and 10% for this one. And if you think, why does she care about the percentages and points? You will care and I care because I want you to see how you are going to be assessed. If you have no idea how you're going to be assessed, then you're going to be unhappy and I will be unhappy. All right, so for 20% credit on this problem, we want to see what r prime of t will be, r double prime of t will be. That's going to be a piece of cake. And of course, it's maybe the reward is too big for that, but that's life. Minus a sine t, a cosine t, and b. T is in infinity, so I have an infinite cylinder on which I draw an infinite helix coming from hell and going to paradise. So between minus infinity and plus infinity in terms of time, I'm gonna draw a beautiful infinite helix. And this is what I posted here. What's the acceleration of this helix? Minus a cosine t, minus a sine t, and 0. Quick question for you. Well, you guys are fast. Maybe I shouldn't go ahead of myself. Nobody's asking me what the speed is right now. So why would I do something that's not on the final, right? So let's see. T, you will have to compute the speed when you get to here, but wait until we get there. What is Mr. T? Mr. T will be the tangent vector. So the velocity is going to look like a crazy guy, long vector. The normal unit vector says, I'm the tangent unit vector. I'm always perpendicular to the direction. I'm of length 1.
I thought the tangent was parallel to the direction of motion.
Yes, the direction of motion is this. Look at me. This is my direction of motion, and the tangent is in the direction of motion.
You said it was perpendicular.
I said perpendicular because I was thinking of ahead of myself at n, and I apologize. So, thank you for correcting me. So, T is the tangent unit vector. I'm going along the direction of motion, and it's going to be perpendicular to T, and that's the principal normal unit vector. Principal normal unit vector. And you're going to tell me what I'm having here because I don't know. T is minus a sine t, a cosine t, and b divided by the speed. That's why I was getting ahead of myself thinking of the speed that you need later on anyway, but you already need it here, right? Because the denominator of this expression will be the speed. Magnitude of r prime. What is that? Piece of cake, square root of the sum of the squares of square root of a squared plus b squared. Piece of cake. I love it. So what do I notice? That although I'm going on a funny curve, which is a parameterized helix, I maybe expected something wild in terms of speed. Well, the speed is constant.
Wait, hold on. Go back to the it shouldn't be the square root of negative a sine t squared.
And what are those? A squared sine squared plus a squared cosine squared plus b squared. Right? And but sine squared plus cosine squared is 1 from trig, so you get a squared plus b squared. Good. Now, let's go on and do the n. The n will be t prime over magnitude of t prime. When you do t prime, you'll say, wait a minute, I have square root of a squared plus b squared on the bottom. On the top, I have minus a cosine t minus a sine t. And 0. We have time to finish, I think so. Divided by the magnitude of this fellow. And you say, oh, wait a minute, the magnitude of this fellow is simply the magnitude of this over this magnitude. And we've seen last time this is the magnitude of this vector. A, right? Good. Now, so the answer will be n is going to be a unit vector, very nice friend of yours, minus cosine t minus sine t 0. Can you draw a conclusion about how I should draw this this vector. You see the component in K is 0, so this vector cannot be like that, cannot be inclined with respect to the horizontal. Yes, sir?
Sorry, what happens to the denominator? Square root of a squared plus b squared?
They simplified. This is division.
Oh, okay.
So this simplifies with that, and a simplifies with a. I should leave some things as an exercise, but this is an obvious one, so I don't have to explain anything. Minus cosine t minus sine t. Do you guys imagine what that is? Remember your washer and dryer at home washer. So if you have an acceleration that's pointing inside, like from a centripetal force, the corresponding acceleration would go pointing inside, not outside. That's going to be exactly minus cosine t minus sine t, 0. So the way I should draw the n would not be just any n, but should be at every point a beautiful vector that's horizontal and is moving along the helix. My elbow is moving along the helix. So see my elbow? Watch my elbow a little bit. I'm trying, I swear I'm doing it. So this is the helix. And this is the acceleration, which is acceleration and the normal unit vector in this case are collinear. They are not collinear in general, but if the speed is a constant, they are collinear. Then n and the acceleration. Yes, sir?
How do you know it's pointing with the central axis?
Good question. Good question. Well, yeah. Let's see that. Plugging t equals 0. What do you have? Minus cosine 0. Minus 1, 0, 0. So you guys would have to draw the vector minus 1, 0, 0. That's minus I, right? So that when I start here, this is my n. From here to here. From the particle to inside. So I go like that. All right, so this is the normal principal vector. I'm very happy about it.
Yeah. Isn't the normal principal vector, is it the derivative of t, or is it just
It was
t?
by definition. It's in your notes, t prime over the magnitude of
So then, why didn't you take a derivative of the...
I did.
No, I see you took a derivative of t of...
This is t prime.
Okay.
And this is magnitude of t prime. Why don't you try this at home, guys, slowly, until you're sure this is what you got. So I did the derivative of that.
Okay. I saw that.
This is a damn constant goes up.
So you...
So when we have k times a function and we prime the product, k goes out. Lucky for us. Imagine how life would be if it weren't like that. So the constant that falls out is 1 over square root of when I derive. And then I have to derive this whole function inside. Right? So I would suggest to everybody, not just to you, go home and see if you can redo this without looking in the notes. Close the damn notes, open, and then you look at it's line by line, all the derivations. Because you guys will have to do that yourselves in the exam, either midterm or final. Anyway, reparameterize in arc lengths to obtain a curve. I still have time to finish the problem. Reparameterize in arc length to obtain a curve rho of S. How do we do that? Who is S? First of all, you should start with the S and then reparameterize. So you say, hey teacher, you tried to fool me, right? I want S to be grabbed as a parameter first, and then I will reparameterize the way you want me to do that. So S of t will be integral from 0 to t square root of a squared plus b squared d tau. Yes. S of t will be what? Who's helping me on that? Because I want you to be awake. Are you guys awake? The square root of that is the constant gets out. Times t. So what did I tell you when it comes to these functions? Well, I have to turn my head and bend it like this. This was the alpha of t, or S of t, and this was t of s, which is S inverse, well, it's the inverse function. I'm not going to write anything stupid, but this is practically the inverse function of S of t. I told you what's easiest to do, put it here. T has to be replaced by, in terms of S, by a certain expression. So who is t? and you'll do that in no time in the exam. T pulled out from there will be just S over square root A squared plus B squared. S over square root A squared plus B squared. And S over square root over, okay? So can I keep the notation out of S? No. It's not mathematically correct to keep out of S. Why do the books sometimes, by abuse of notation, keep out of S? Because the books are not always rigorous. But I'm trying to be rigorous. This is an honors class. So, how do I rewrite the whole thing? R of T, who is a function of S. T as a function of S was, again, S over square root A squared plus B squared, will be renamed rho of S. And what is that? That is A of cosine of parentheses S over square root A squared plus B squared, comma, A sine of S over square root A squared plus B squared, and B times S over square root A squared plus B squared. So what have I done? Did I get my 20%? Yes. Why? Because I reparameterized the curve. Did I get my other 20%? Yes. Because I told people who S of T was. So 20% for this box and 20% for this expression. So what have I done? On the same physical curve, I have slowed down, thank God. You say, finally she's slowing down, right? I've changed the speed. No, on the contrary. If A would be 4 and B would be 3, I increased my speed multifold 5 times, right? So you can go back and forth between S and T. What does S do compared to T? It increases the speed 5 times. Yes, sir.
Parameterize just by taking the integral from 0 to T of whatever prime of tau is.
Exactly. This is. So my suggestion to all of you, it took me a year to understand how to reparameterize because I was not smart enough to get it as a freshman. I got an A in that class. I didn't understand anything. As a sophomore, I really, because sometimes, you know, you can get to get an A without understanding things in depth. As a sophomore, I said, okay, what the heck was the reparameterization? I have to understand that because it bothers me. I went back, I took the book, I learned about reparameterization. Our book, I think, does a very good job when it comes to reparameterizing. So if you open the 10.2 and 10.4, you have to skip. Well, am I telling you to skip 10.3? That's about ballistics. If you are interested in guns and all sorts of like how the bullet will be projected in this motion or another motion, you can learn that. Those are plane curves that are of interest in physics and mathematics. But 10.3 is not part of the material required. Read 10.2 and 10.4. You understand this much better? Yes, ma'am.
Will the midterm and the final just be like a series of problems, or will it be anything?
This is going to be like that. 15 problems like that.
Will it be anything like super in-depth, like the extra credit homework?
Isn't that in-depth enough?
I mean, like
okay, this is going to be extra.
Yeah.
So I would say at this point, the way I feel that I'm ready to put the extra credit there. My policy is that I read everything. So even if at this point you say extra credit and you put ATTN for me, say, look, I'm doing the extra credit here, then I'll be ready and I'll say, okay, what did she mean? Length of the arc, which arc from here to here is ready to be computed. And that's going to be, you can include your extra credit inside the actual problem. I'll see it.
Yes.
Don't worry.
No, just what I mean is like, just like a casual problem on the test or midterm or whatever, would it be like an extra credit problem in itself? Like, I know there will be extra credit, but like, the kind of proving
that is decided together with the course coordinator. The course coordinator itself said that he is encouraging us to set up the scale so that if you do all the problems that are written on the exam, you get something like 120%. If everything is perfect.
Okay, if we can,
So it's sort of inbuilt in there, yes.
if we can do the web work, is that a good indication that we'll do it?
Wonderful. That's exactly, because the way we write those problems for the final, we pull them out of the web work problems we did for the homework. So it's square root of a squared plus b squared times pi over 2. So what have I discovered? If I would take a piece of thread paper and I would measure from this point to this point how much I traveled in inches, from here to here, that's exactly that. Square root of, this would be like a 5 times 3.1415 divided by 2. Yes, sir.
So, in the integral of a squared plus b squared, I know that that's supposed to be the integral of magnitude of r prime.
The speed, integral of speed.
Right. So, which
From A
is
to
the
B.
r prime, right? The magnitude of r prime.
Yes, sir.
Okay. So, r prime was
Velocity.
a sine or negative a sine t, a cosine t, and then b. So, where did the square root of a squared plus b squared come from?
That's from the magnitude.
I just erased it. Okay, so you have minus a sine t, a cosine t, and b. When you square them, what did you get? Yes, the same thing.
So that's just
the square of that plus the square of that plus the square of that.
so that's just like a 2D
Under square.
representation of the top one.
This side.
This is r prime.
Cancel or become 1.
I just did the magnitude of r prime, which is the speed, right?
Right.
The magnitude of this is the speed, which is square root of a squared plus b squared.
Okay.
Is that clear?
Yeah.
I can go on if you want. So again, square root of the sum of the squares of this, and that is exactly square root of a squared plus b squared. Keep this in mind as an example. It's an extremely important one. It appears very frequently in on tests, and it's one of the most beautiful examples in physical applications of mathematics to physics. I had something else that was there. Yes, ma'am?
I was just going to ask if
The
the letter
curvature?
curvature.
That's exactly what I want. And when I said I had something else for 20%, what was K? K was rho double prime of S in magnitude. So I have to be smart enough to look back at the rho of S. And rho of S was the thing that had here. That's going to be probably the end of my lesson today. Since you have so many questions, I will continue. I should consider the chapters finished, but I will continue with a deeper review, how about that, on Tuesday with more problems. Because I have the feeling that although we covered 10.1, 10.2, 10.4, you need a lot more examples until you feel comfortable. Many of you not, maybe 10 people, they feel very comfortable, they get it, but I think nobody will be hurt by more review and more examples and more applications. Now, who can help me finish my goal for today? Is this hard? This is rho of S. So you have to tell me with the derivation, is it hard? No. Minus a sine of the whole thing times 1 over square root of a squared plus b squared, because I'm applying the chain rule, right? Let me change color. Who's the next guy? A cosine of S over square root a squared plus b squared. I'm not going to give you this as an exercise, because you're going to hunt me back asking me why I got this. So I want to make it very clear. B times 1 over square root a squared plus b squared. So are we happy with this? Is this understood? It's a simple derivation of the velocity. We are not done. We have to do the acceleration. So the acceleration with respect to S of this curve, where S was the arc length parameter, is really easy to compute in the same way. What is different? I'm not gonna write more explicitly because this should be visible for everybody.
The X and the Y are negative. That's the only difference in the
Good. Minus A over. I'll wait for you to simplify because I don't want to pull two roots out.
A squared plus
A squared plus B squared. And why is that, Nitish? Very good. Because you have once and twice from the chain rule. So again, I hope you guys don't have a problem with the chain rule, so I don't have to send you back to calculus 1. A over A squared plus B squared with a minus. Why with a minus? Somebody explain.
Here's the derivative of cosine equals.
Here's a cosine, and here's a minus sign from deriving. I have a minus and a sign. And finally, thank God, 0. Why 0? Because I have a constant that I am deriving with respect to S. Is it hard to see what's up, what's going out? What is the curvature of the helix? It's a beautiful, beautiful function that is known in most of the advanced calculus, multivariable calculus, and differential geometry classes. What did you guess? Square root of sum of the squares of all these guys. You process it. That's very easy. Shall I write it down? Let me write it down like a silly girl. Square root of A squared, although I hate when I cannot go ahead and simplify it, but let's say this is a baby thing. Now I can say it's A over A squared plus B squared, finally. So, I'm going to ask you a few questions and then I'm going to let you go. It's a punishment for 1 minute. Okay, if I have the curve we had before, the beautiful helix with a Pythagorean number like 3 cosine t, 3 sine t, and 4t. What is the curvature of that helix? 3 over 5, excellent. How about my helix? What if I change the numbers in web work or on the midterm and I say it's going to be, it could even be with a minus, guys. It's just the way you travel it, it would be different. So whether I put plus minus here, you will try on different examples. Sometimes if we put minus here or minus here, it's really not going to matter. Let's say we have cosine t, sine t, and t. What's the curvature of that parameterized curve? 1 over 2. Excellent. So you got it. So I'm proud of you. Now, I want to do more examples until you feel confident about it. I know I got most of you to the point where I wanted, but you need more review, definitely, and you need to see more examples. Feel free to read the whole chapter. I would, if you don't have time for 10.3, skip it. 10.5 is not going to be required. So if I were a student, I would go home, open the book, read 10.1, 10.2, 10.4, close the book. It's actually a lot less than you think it is. If you go over the most important formulas, then you are ready for the homework. The second homework is due when? February 11th. You guys have plenty of time. Rather than going to the tutors, ask me on Tuesday. On Tuesday, we have plenty of time for applications. Okay. Have a wonderful weekend. Don't forget to email when you get in trouble, okay?